Hello, our project is the Amazon Movies and TV Reviews Sentiment Analysis. This app is built on Streamlit with code hosting on GitHub. Our teammates are Catherine Beyer, Courtney Shamas, and Honor Tukiner. From our app, you can just see the bottom that gives you some instructions on how to navigate with our sidebar for either methods, the Vader lexicon analysis, text blob analysis, or overall performance comparison. So going down to methods, this here is just a description on what we did on the actual data set itself, just to give a little bit more insight on the processes. Going to Vader Lexicon, this is the first package applied to our Amazon reviews data set. So if you hover over, the dark blue is the actual rating, like the stars given on the review itself. And then the light blue is the performance from our sentiment analysis Vader Lexicon package. So this one was pretty comparable to the actual review itself. I think that one performed quite well. Text blob, this is similar to Vader Lexicon. So you'll see the actual reviews versus the text blob review. And then overall performance tab is going to be a side-by-side bar chart comparison of all three. So you're going to have your actual stars on the Amazon review itself, the Vader Lexicon ratings, and the text blob ratings. And here is our GitHub page. This is our main.py. This is all responsible for the code hosting. And you can see more details on the function actually in our written portion. And thank you.
Now that we've seen how the application works, let's look at the code behind the sentiment analysis project. Before the pre-processing step, we first load the Amazon Reviews dataset, limiting the dataset to the movies and TV category. We then print the column names and the first review to get an idea of the dataset's structure. Next, we prepare the dataset for further analysis by taking the first 1,000 reviews from the full dataset and converting them into a pandas data frame. To reduce the dataset further, we also limit the data frame to the text and ratings columns only. Now that we have sufficiently reduced the dataset, it's time to begin the pre-processing steps. This section uses the stop words module from NLTK to create a set of common English words that do not contribute significant meaning to the analysis. These words can be filtered out to reduce noise and focus on more meaningful parts of the text. We also initialize a limitizer using WordNet Limitizer from NLTK. Limitization reduces words to their base form to help normalize the text and ensure that words with similar meanings are analyzed together. The next section includes a preprocessing function that applies common preprocessing techniques. This includes converting the text to lowercase, removing HTML tags using regular expressions, removing punctuation and special characters, splitting the text into individual tokens, also known as tokenization, removing stop words using the list defined in the previous step, and applying the limitizer defined earlier. And finally, we rejoin the cleaned and preprocessed tokens into a single string that is then ready for further analysis. In the final preprocessing section, the preprocessed text function is applied to our Amazon Reviews data frame, and the text is now ready for feature extraction.
In the feature engineering part, we transformed text data into numerical data using vectorization. First, we use count vectorizer to convert the clean text into spare matrix. After this transformation, the matrix had shape of 1000 by 10602. This means we have 1000 reviews and 10602 unique words in our vocabulary. To go beyond word frequency and capture word importance, we use TF-IDF vectorization. This method gives more weight to important words and reduce the weight of common ones. We include both single words and two-word pairs to better understand word relationships. The resulting matrix had a shape of 1000 by 54,921, which means we captured much more context by including bigram. In this project, we used two popular libraries for sentiment analysis, Vader and TextBlob. We compared the predicted sentiment scores from these tools with the actual user ratings. First, we use the Vader Sentiment Intensity Analyzer. This tool calculates the sentiment score for each review, ranging from -1, which is most negative, to 1, most positive. We also added extra features like word count and character count to provide more details. Then we mapped the weather sentiment scores to 1 to 5 rating scale so we could directly compare them with actual user rating. This bar chart shows the comparison between actual user ratings and the weather predicted ratings. We can see that the weather model seems to give higher scores to reviews with the middle ratings than they actually deserve. Next, we use TextBlob, another tool for sentiment analysis. With TextBlob, we calculate the sentiment polarity for each review, just like weather. These polarity scores range from -1 to 1. We also map the TextBlob polarity scores to 1 to 5 rating scale. TextBlob doesn't capture sentiment trends well. There are noticeable differences when compared to actual ratings. We compare the actual ratings with the prediction from both weather and TextBlob side by side. In this sample, weather appears to have better predictions than TextBlob. However, it is possible that the result might be different if we analyze the entire dataset using the same method.